Okay, in chapter 6, we're going to talk about three-dimensional figures. So this section specifically is going to talk about plotting points. So in geometry, you worked with objects that existed in different dimensions. You considered lines and line segments, which only have one dimension, length. You've also looked at flat shapes like circles, rectangles, trapezoids. They have two dimensions, length and width. But then we now have prisms, cones, and most other objects that we encounter in the real world have volume. Therefore, there are three dimensions, length, width, and height. So when you worked with graphs in Algebra 1, you represented points, the number line, and curves of a two-dimensional flat surface called the XY plane. So that's what you guys did in the past. You've done this XY plane. So far, you've only been able to represent relationships with at most two unknowns, usually the variables X and Y. However, many problems, like some that you've done already, have more than two unknowns. Today, you and your team will build a model that will help you graph in 3 dimensions. As you work on this lesson, consider the following questions with your team. How can we plot a point in 3 dimensions? How can we write the coordinates of a point in 3 dimensions? And how can we show 3 dimensions on a flat paper? Because we are only going to be using paper to represent this. So the first problem, consider when it's appropriate to graph a situation in 1, 2, and/or 3 dimensions. It may be helpful to think about your experience representing numbers and relationships on a number line or an XY plane, and how you can adapt your knowledge to work in 3 dimensions. Discuss each question with your team before writing your response. So what you're going to be working with in your teams is you're going to go through A, B, and C. So go ahead and read A aloud, answer A, move on to B, etc. How can you represent the solution of x equals 5 graphically? A straight line through x equals 5. Absolutely. That is one way to represent that graphically. Can you think of another way to represent that? Yes, a number line. So way back when, 3rd grade, I don't know, it might have even been before 3rd grade, you guys learned the number line. And then you use the number line to learn how to add and subtract numbers. But we had, what do we call this dot here? What's the fancy word for a dot? A point. Or we have a, what's this called? A line. So we can either graph x equals 5 as a point or a line. Okay, moving on to B. Now we have x plus 2y equals 5. What is that going to look like? X plus B form. It's just a line. It's an oblique line, not a vertical line, not a horizontal line. It's an oblique line. Easiest way to probably graph it is either putting it in the slope-intercept form or finding your intercepts. X-intercept is when y is 0, so x-intercept's at 5. Y-intercept is when x is 0, so that's 2.5. It's an oblique line with a negative slope. Now we get into part C. Now we threw in a new letter. We threw in Z. So when 1 dimensions, we had a point or a line. In 2 dimensions, we have a line. What do you think is going to happen in 3 dimensions? You guys laugh actually when he says triangle, but it actually will look like a triangle when we learn about these tomorrow. But it's not a triangle, but it's going to look like it when we graph it 2-dimensionally. Starts with a P, point, line, plane. It is a plane. So today we're just talking about the fact that it's a plane. We're going to graph points today in 3 dimensions. Tomorrow we'll learn how to graph the plane. So in 6.2, we're going to learn again how to graph the solutions of equations with 3 variables. In order to do that, we're going to use 3-dimensional coordinate system. So I gave you guys all that resource page. You cut it out. What I need you now to do, you're not going to tape it, but you're going to fold it along the solid lines. You're going to make sure that the grid is on the inside of the shape, and that will give you your 3-dimensional solid. When you look at the grid, you're going to notice that X looks like it's going off to the left and Y is going off to the right. It's not. It really looks like this. X is coming towards you, Y is going to the right, and then Z is going vertically. So with your little shapes that you guys made, make sure the X-axis is pointing directly at your face. Y goes directly perpendicular, Z goes straight up and down. So what you are going to do now is from your little XYZ plane model that we made, you are going to take the cube and you are going to move it where the X value is 4, so going towards you is 4 units, and where your Y value is 2, so going 2 units to the right. So take that cube and put it there. So that's just using the X and Y, just like always. Now what you're going to do is you're going to take that Z value, and you're going to take that cube and you're now going to move it up 3 units. So you're going to have to hold it in the air. And you now have plotted the point 4, 2, 3. So now that you have your coordinate point, now you're going to do the same thing, but this time you want to make the X3, the Y4, and the Z2, and then go ahead and write that coordinate point. Okay, which means, what's the X value of my coordinate point? Y value and Z value. So now, the model that you created, so this little contraption that we created, is only a portion of the entire coordinate system. It's where X is positive, Y is positive, and Z is positive. So what I need you to do is I want you to talk in your teams about how many models would you have to put together to create an entire model that represents the entire three-dimensional coordinate system. Keep in mind the regions that you would need to graph points like this, where both Y and Z are negative, or where all 3 of them are negative. So talk with your teams about how many of those little models you would need to create the whole system. So my question to you is how many areas have positive Z's? 4. This one in the hallway, Samp's room, and the other hallway. 4 of them have positive Z's. How many have negative Z's? 4. Therefore, how many total do I have? And they are called octants. When we have a coordinate system, there are 4 quadrants. In a 3D system, there are 8, so they are called octants. So now what we're going to do is we are going to build a 3-dimensional shape to help us look at these coordinate points. So in your groups, you can use the cubes, and I'm going to ask you to build 2 by 2 by 2 cubes. So it should be a solid cube. You're only going to be able to make one of those in your teams because you don't have enough for all of them. If you don't have the cubes, then you can just kind of think through it. But please build a 2 by 2 by 2 cube, and then you're going to name the vertex farthest from the origin. What is the vertex farthest from the origin? What is the coordinate point of it? 2, 2, 2. So now, if you haven't done so yet, build a rectangular prism that is 2 units in length along the x-axis, 1 along the y-axis, and 3 along the z-axis. And now I want you to use the coordinates to name the vertex that is farthest from the origin. Okay, what is the vertex that is farthest away from the origin? 2. What's the next number? 1, and then 3. Okay, if you have not done so, please list all of the other coordinate points. So quickly go through and label all of the coordinate points. How many should you have? 8. There are 8 vertices on a prism. You already have one of them. And the other one is 0, 0, 0. Then find the other 6. Okay, what other one is on the x-axis? On the x-axis, what's the first number? 2, and then 0, 0. Okay, which one's on the y-axis? 0, 1, 0. Good. Which one's on the z-axis? 0, 0, 3. Good. And then when I list all the rest of them, so there's all of them. So I can plot all of those points over here now, or I can just look at what I know based on how far my coordinate point is. So 2, 1, 3. So I go 2 along the x-axis. Oh. Thank you. So I went 2 along the x-axis. I went 1 along the y. And what we just created there is the base of my prism because it started at the origin. So what I did is I went 2 along the x, 1 along the y, and then that makes the rectangle for the base. And then the height of this prism, it all goes up 3 units. So all these go up 3 spots. So from this point, it goes 1, 2, 3. From here, it goes 1, 2, 3. From here, it goes 1, 2, 3. And from here, it goes 1, 2, 3. So I have, in essence, 2 parallel bases. And then I can connect them with their heights. So sorry about my not straight lines. But what that does is it gives me a prism, and it shows me this is the point that is the farthest from the origin. You can see that this is opposite sides of the prism. Next problem, do this quickly. Build a rectangular prism that has vertices at 1, 0, 0, 0, 0, 4, and 0, 3, 0. And then use that prism to find the other 5 vertices. And then look at it as if it's negative. Take 2 minutes to do that, please. Check all of your coordinate points. You should realize all the time your x values in A are either 1 or what? 0. Your y's are either 0 or 3, and your z's are 0 or 4. So if you have a number other than those, that's kind of how you can check to make sure that you have everything correct. So now what we're going to do for the last part of today's lesson is we are going to plot our coordinate points using our isometric dot paper. So isometric dot paper looks like the following. You have to draw the XY axis on just like you have to when it's a coordinate system. So you can decide where you want to put it. I'm going to dual screen this to make it easier to see. So I'm going to draw my, oh, that's not good. Let's try that again. They have to be straight lines coming from the same points. And then what I'm going to have you guys do is once you've drawn those lines in there, please remember this axis is X, this one is Y, this is Z, and you're going to plot these 3 points. So please take a minute and plot these 3 points. Go along your x-axis, then go along your y, then move with your z. Why are we grumbling? What's wrong with these 3 points? They're the same. So when I plot this first one, it's 0 according to x, 1 according to y, and then -1 down for z. So there's my first point. And then for 1, 2, 0, it's 1 according to x, 2 according to y, and 0 up. And then my third point, 2 according to my x, 3 according to my y, and 1 up. So they all end at the same spot, but they're not the same. Let me show you why. When I plot the point 2, 3, 1, it's 2 this direction, 3 this direction, so here's my base, and then 1 unit up. That's this one. When I plot 1, 2, 0, 1 this direction, 2 this direction. And that's a flat 2-dimensional surface. So, homework is 611. Work on those problems for tomorrow. We'll talk more about plotting points tomorrow as well.